These are the notes for Algebra 2, Section 6.1, and we're looking at rational exponents. Before we actually get started in what we're looking at, we do need to do some vocabulary stuff. The first one is, in general, if for an integer n greater than 1, n then would have to be 2, 3, 4, 5, something like that. If b to the nth power equals a, then b is an nth root of a. Let's look at that with a concrete example. For instance, I could say that 2 to the third power equals 8. 2 to the third power equals 8 because 2 times 2 times 2 is 8. That means that 2 is a third root of 8. And I could write that. 2 is a third root of 8. Right? That's the way we would say 2 to the third equals 8. So 2 is a third root of 8. An nth root is written this way. We have our radical sign, remember from square roots, with a little n above the radical sign just to denote what n would be, with a underneath the radical. N, in this case, is the index of the radical. Now, we've seen radicals before. We know that the square root of 4 equals 2. And we don't have a number here. That's because there's an understood 2 in front of the radical. We put the n there if there isn't a 2, if it's not the second root, if it's not a square root. We need whatever root we have here. So the square root of 4 is 2 because 2 squared equals 4. 2 is the second root of 4. We could also write this in a different way, and we're going to see that in just a minute. Let's go back to our example here. 2 is a third root of 8. Well, we could write that as the third root, notice there's 3 here to denote that this is the third root of 8 equals 2, because 2 to the third equals 8. So that's the notation that we're looking at here. Now let's look at how we're actually going to use this. We have a chart here, and the first thing we have to know is that we're assuming that the power of a power property applies to rational exponents. That means that the power that says that if I have a to the m raised to the nth equals a to the m times n. Right? If I raise a power to a power, I multiply the exponents. That is the power of a power property. Now, if we assume that this works, even when exponents are fractions, rational means fractions, then we can break this down in some useful ways. I have a to the m over n, which I could, assuming that this power works, the power of a power property works, I could rewrite this as a to the 1 over n to the mth power. And you can see that if I did that, that would be a to the 1 over n times m, which multiplies out to get this rational exponent. So I could rewrite it in this way, a to the 1 over n to the mth power. Using this, I can convert a rational exponent into a radical. And the way I do that is fairly straightforward. N is my index, so I have the nth root of a. I put parentheses around it and raise it to the mth power. All right. One useful thing to notice here is that 1 over n denotes that we have the nth root of a. And that works for all of them. 1 over 2 would be the square root. 1 over 3 would be the third root. 1 over 4 would be the fourth root, so on and so forth. And we have something very similar under a to the negative m over n. Of course, we know using the negative exponents property that we have to take the reciprocal of this term to make it positive. So the first thing that we would do here would be to take the reciprocal. That would actually be our first step. We would change a to the negative m over n to 1 over a to the m over n. And from there, we would go exactly the way we just went. A to the m over n would be 1 over a to the 1nth to the m, which then simplifies to 1 over, if we wanted to write it as a radical, the nth root of a to the mth power. So we can do that. We are going to get a little bit of practice converting from a to the m over n to the radical form and back and forth. It's kind of useful to notice that I have a fraction m over n, and in radical form I have the nth root raised to the mth power. So n and m. All right. We're going to see exactly how that works in some examples. So let's look at some examples where we want to change the format. In example A, we want to change from a rational exponent form to a radical form. So right now we're looking at 12 to the 1/3 power as a rational exponent, and we want to change it to radical form. Now to do that, it's actually fairly simple. We know that the top number here is going to be m. And we know that the bottom number is going to be n. So our format would simply look like this. We would have 12, that's our a. The nth root, so the nth root raised to the mth power. N is 3, m is 1. So we have the third root of 12. Now I could put the parentheses around it and make it 1, but of course anything raised to the first power is just itself. So my final answer, the simplified form, would be the third root of 12. I can skip, I usually don't even have to write these two middle steps. As long as I can identify m and n, I can usually jump straight to my final form. I wrote these steps out just to illustrate the thought process that went into it. Let's go the other direction. Here we have this in radical form, and we want to change it into exponential form. So I look at my terms here, and I can see I have 3 and 7. Now 3 is my n, because my exponential form has the nth root, the index, and 7 is my m. Now I know that I want to end up with a fraction here. So start with my 10, that's my a. My fraction is m over n. So m is 7, so it's going to be 7 over 3. That is my final answer. Notice I just went straight from the answer, or from the question to the answer, because as soon as I know m and n, I can just put it in whatever format I need. Alright, let's use this to evaluate an expression. We should be able to do most of the evaluation problems that we're going to get on without calculators. We should be able to do it in our heads. And all of our answers should either be whole numbers or fractions. So let's keep that in mind as we work through these. Now, I want to evaluate 8 to the negative 4 over 3. 8 to the negative 4 over 3. Now, the first thing that I need to do is make it so that it's not negative. Right? That's going to be my first step. So 8 to the negative 4 over 3 becomes 1 over 8 to the 4 over 3. I'm looking at rational exponent form right now, so I'm going to leave it as a rational exponent. But regardless of what form I want to do this problem in, this is my first step. I'm going to change 8 to the negative 4 over 3 to 1 over 8 to the 4 over 3. Now, my next step, I want to split this up. I know I have m on top and n below. And just to illustrate the steps, I'm going to make a few extra steps here. So I'm going to split this up, put the 8 in parentheses. I'm going to split up the m and n. So 8 to the 4 over 3 is 8 to the 1 over 3 to the 4th power, because 1/3 times 4 is 4/3. Now, that is a useful step here, because I can tell what 1/3 of 8 would be, because 1/3 of 8 is just 2. Now, 1/3 of 8 is just the 1/3 power of 8. That's the 3rd root of 8. 8 to the 1/3, if you are not sure about this, you can put it in the calculator, is 2. But it's still to the 4th power. Now I have 2 to the 4th power, 2 times 2 times 2 times 2, 1 over 16. And that is my final answer. So I started with 8 to the 1/4, split into the basic root. I call this the basic root because there's m is 1. In this case, the number on top is 1. 8 to the 1/3 is 2. 2 to the 4th is 16. Now let's work the same exact problem, but this time we're going to do it in radical form. In either form works. It doesn't really make a difference. First step, though, is exactly the same. We need this to be positive. To make it positive, we take the reciprocal. So we have 8 to the negative 4/3 becomes 1 over 8 to the 4/3. But this time, we're going to change this into radical form. And radical form, for this, we have m on top and n below. So according to our radical form, we would have 1 over the 3rd root of 8 to the 4th power. And again, the 3rd root of 8, we know, is 2. So this is 2 to the 4th power, which again is 1 over 16. And that is our final answer.